But the thing is, he's very organized. So in software engineering, it's very easy to look at the title of the class and assume it's a programming class, and it's really not. It's the art of planning out a project, kind of tending towards when you have multiple people working on it, but ultimately following all those planning steps so that the software almost writes itself in the end. In fact, there's tools out there that if you put your requirements and your specifications, you do that in the right kind of format, it'll actually generate a whole bunch of the code. So it's not that there shouldn't be programming aspects to software engineering, but it should probably be 75% planning, 25% programming. And if somebody like me taught the class, it would be significantly higher percentage programming. Not that I would gloss over the other stuff, but the other stuff would become less formal, I think. And I think there's importance to it, even though it might not be fun. All that, the tedious coming up with the requirements, then transitioning to the specifications. And then if you look at any of the tools for, kind of creating Microsoft projects or something like that for creating the storyboards for stuff, all that stuff is tedium, but has a big value later on when you're on a team of 7 people working on the same project and everybody's pulling in different directions. Super important class, probably not the class you want Lippman teaching, because it doesn't really benefit you in the end, because I'll take you down a fun but less viable path for industry.
Well, I mean, everyone has their strengths and weaknesses.
Yeah, but 325 would be my bread and butter, but my schedule was too full this semester. I would prefer it over a couple of classes I'm teaching. No, I like this class. I like this class. Let's see. So this is 300. Oh. Well, who wouldn't? Well, shouldn't they be extremely difficult? The best part is I usually make up the assignments right at the end of class. Like, I don't know even what's happening. I don't even think through it. Just like, let's see if it works. Is this even solvable? Well, we're going to find out next class. What's up? All right. So let's see. This is not our class. That was 450. But we're also doing merge sort again in 450. No, I purposely do merge sort multiple times, because just like you guys are seeing it here, you saw it in 200, scared the crap out of you. Now you're seeing it again when you're a much stronger programmer, and it's less terrifying. But right here we talk about kind of the value of merge sort. So that's something we could talk about in here. When would we use merge sort? Because typically we might say, well, merge sort seems scary. So if we are implementing a sorting algorithm professionally, our concept as a programmer might be that, the more complex the algorithm is, probably the better the sort is, right? And that's not necessarily true for merge sort unless the infrastructure that's running on supports it. If you're just running, let's just take the extreme. If you're running merge sort on a single CPU computer, that can only technically do one thing at a time, merge sort's horrible performance. It's using up a whole bunch of memory and not gaining any performance. But merge sort operates off the idea that you can take a collection of values and you can sort parts of that simultaneously. So if you can get different workers working on different parts of the list, that then increases the speed of the sorting, because the actual merge step for merge sort is very quick, right? Even though it felt tedious, it's just 3 if statements, right? With just some, like, here's the winner, that kind of stuff. So that actual merge step is very fast. So if we can split it up divide up the work into, let's just make it up, let's say 50 different workers, kind of like raking leaves at the university. Instead of having one really fast processor, really fast leaf raker raking the leaves, we can now have 50 people raking the leaves, and even if they're slower at raking, you're probably going to get the campus cleaned up more quickly because you have so many people working on the problem. And somebody raking leaves by the field house doesn't impact somebody raking leaves by the lake, right? So those are types of problems that can be divided up. That's where merge sort shines. And since we're in a world now where they have cloud computing and distributed applications and stuff like that, where we can even leave our core computer, you know, fine, we have computers now that have quad core, 8-core, whatever. You have server class processors that have 48 cores. AMD makes some 48-core processors. That's a lot of simultaneous stuff, but that's only going to benefit you if you're using it to solve problems that benefit from dividing up the labor, right? So merge sort shines in those situations, which tends to be in the direction that we're moving technologically. You know, Google is not running on a single web server. When you go to google.com, it's handing you off to whatever computing farm is in your region, and then whatever computer at that computing farm is least busy right now, and that's the dude that's serving your Google requests, right? So that problem is a distributed problem, and that's something that we just generally call it the cloud, right? That's what things are happening with. That's how things are going now. So merge sort's great for that, but crap for single core processors, but interesting from a recursion perspective because it's terrifying with the 2 calls to recursion. So there's your, so in the 450 class, we use merge sort as an example of multiprocessing. So we're actually creating multiple, probably have it up here. Yeah, so here's merge sort in C. You said, I mean, so you should recognize this function. This is our merge function with those if statements, right? Nothing special there. But where things change is down here. Wherever you see this command called fork, a clone of this process is being created. A brand new child process is being created. And here's a second call to fork. So instead of recursive calls, which is asking the same CPU to take this over, we're just creating children to go work on those halves, right? So that's applying. So now you're seeing that merge sort doesn't have to be recursion. You can just, you're handing off the task to somebody else who knows how to do the same thing. And then this also has like shared memory in it and something called signals and all sorts of other cool inter-process communication junk. Things you probably talked about, everybody in here had 350? So stuff you might talk about in 350 in terms of processes, and on an operating system, it might be beneficial for one process to talk to another process. In 450, we actually write the code to make them talk and have like an array that's shared across the entire operating system, that type of thing with shared memory and being able to have one process scream some message out and have other processes hear that message and say, okay, I'm good, I'm ready, yada, yada, yada. So like up here, this is our signal handler for this guy. The parent is waiting for both of their kids to say, I'm done sorting my parts. That's what that if statement says. So this, each time this gets called, kid number increases by 1. Once you got 2 kids who scream back that says, Mom, I finished my part, then mom can merge them. That's what mom does. And then mom tells their parent, I'm done. Screams at their parent. And because they're one of their parents' 2 kids. Interesting? Yeah, but it goes, you know, every time you would have a recursive call, the child becomes a new parent of twins, right? So the children ultimately yell at their parents, who then yell at their parents, who then yell at their parents. You're seeing recursion done across separate processes rather than recursively within a single process. So that's where merge sort makes sense in multiple classes, teaching different concepts. Plus, it's just fun because it scares students. I really get a lot of entertainment from that. All right, so let's start off with this. It's my favorite coding class. Probably 470, the one where we write the programming language. Yeah, that one terrifies you. Oh my gosh. Day 4 of that class, you got 3/4 of the class crying. It's hilarious. Just pure joy. Huh? Oh, this one. Yeah, there we go. Thank you. But 470, which I think most of you are probably taking in the fall, right? 470 is in the fall. 470, I think, is the class where you become a computer scientist. So it sounds maybe scary or whatever that, oh, we're writing a programming language in there, but you're going to find that that's not actually all that complex. A programming language is just like any other program. But it's the class where recursion becomes second nature to you, because I purposely pick a language that doesn't support loops. So anytime you would do a loop, you write it recursively. Well, what ends up happening is when you come out of that class, you almost have trouble thinking iteratively because you've been so used to recursion. But now all of a sudden recursion is no longer this intimidating thing. It's just another tool for problem solving. Yeah. Yeah. Yeah, one of our hackathons, when we used to do the battle hacks, the professional hackathons, we went to Raleigh, North Carolina, and trying to think what language. I wrote a programming language that supported everything but recursion in 24 hours. And I'm thinking, what language did I use? Because I like picking something interesting that I maybe haven't necessarily worked with before. So the actual syntax is written in JSON, but the, or JSON-esque, let's say. But I think the coding language I used for it was something along the lines of Google Go, but it wasn't Go. It was something like that, some up and coming whatever language that may or may not take off. And then what I think you guys were around when I did that, the dice roller and the chicken language. Yeah. So and those things are fun because it allows you, and actually that example, that chicken language, that has a lot to do with 325. Because that chicken language effectively was a software-based thing where every function was some number of chickens. So that's like on a CPU saying, do magic trick 0, do magic trick 1, do magic trick 2, do magic trick chicken, do magic trick chicken, so on and so forth. All these things connect. You know, that's where Dr. Locklear's dissertation on the grand ideas of computer science make a lot of sense, because there's this circular relationship between all these different ideas that all come back to the same center core. And you can talk about the same stuff from different angles. Just fascinating. Yeah, so 470 would be my favorite class. I like 450. I like 300. I like 200, 250, 300, like all of those. Like 548. I would like 325. I pretty much like most of the classes I teach. There's a couple of grad classes that I have to teach that I'm less interested in. Our 560 class deals with the mean stack. So it's MongoDB for a database, Express, Node.js, and Angular. I tend to not like web stuff too much. I just find it less interesting, but programming's programming. All right, so I think last time I mentioned that if you had anything you wanted me to cover, go over, things like that, for the final, any topics, I can go and re-go over those. Then I'll go through our slides and kind of point out what I think is most important. Then you can certainly ask questions again. So is there a specific topic or anything that you want me to review before I go through the slides? Either in person or online, folks. Go ahead.
So the midterm had almost all the programming questions about means and this.
Mhm.
There's going to be something like that on there. There's like most of
Well, maybe because having them deal with linked lists really has more to do with the nature of the questions I'm kind of able to ask that you can sort of finish in a period of time. So, I mean, there will certainly be things on there dealing with stacks. There'll probably be something on the exam dealing with binary trees. But asking a programming question related to binary trees is a little bit tougher. And it has more to do with it's less obvious to come up with practical examples of binary trees. Not that there aren't practical examples, just in a test situation, it's harder to come up with them. So questions dealing with binary trees would probably be more along the lines of me giving you a tree and saying, show me the order for, that you'd visit these nodes in pre-order, post-order, in order, something like that. Showing that you understand what a binary tree is and how traversing a binary tree can make a difference. So I don't know, long-winded answer, but typically it has more to do with the question I want to ask, because I'm probably thinking about the same kinds of questions that I would ask in like in a 250 class, but just instead of arrays, I'm thinking about linked data structures, something like that. All right, what else? Oh, probably. Well, I mean, I might not ask it directly, but I mean, that's an important concept in C++. But that concept transcends all these different languages. I mean, the same thing's happening with Java. Java just doesn't have a special syntax for it. If you were to create a random R equals new random and you print out R, that's a pointer. That's a memory address in Java. So R dot resolves that memory address. Saying R dot in Java is the same thing as saying star R dot in C++. We just don't have that special syntax in Java. They've removed the pointer syntax. That's why we don't have the arrow in Java, because we don't have the ability to work directly with memory. Therefore, we don't have the ability to explicitly say resolve this memory address to the thing that's there. Whereas in C++, if we have like a linked list pointer L equals new linked list, something like that, to say L add 5, something like that. Here, just since it's gonna do this, we're gonna call it like that, is the same thing as saying star L dot add. Those are equivalents to each other, because when I say L arrow like this, it's saying, oh, you want me to first resolve the address stored in L to the thing that lives at that address. Star L says, give me the thing that lives at that address. Those two things mean the same thing. The arrow just allows you to avoid the star and the parentheses to pull it off. So it's syntactic sugar for something that you're going to often do. Yeah. Correct. Yeah, it's a memory address. A pointer is a primitive type. So it's going to try to, I mean, this is something we cover in the 470 class, but if I say L.add 5 like this, the way these things work is it sends the message add to this value. So it's going to send this message to a memory location, and the thing that's at that memory, it's going to send it to a memory location, not a thing. And a memory location doesn't have functions. It's a primitive type, and primitive types can only hold values, is the idea there. So this is something called message passing. And that's a reason why I like in like Objective-C. So in Objective-C, if we were writing the same thing, we would say linked list pointer L is equal to linked list alloc init, something like that. And then we would say L add 5. Send L the message add passing it a 5. And actually this would probably be called add, probably look more like that in Objective-C. So Objective-C looks a little bit more verbose, but it also exemplifies the idea of a message passing a little bit more. You know, this is kind of like making a phone call. Who are we calling? What are we saying? What additional stuff do we need to send them? Exact same pattern that exists. It just kind of presents the syntax for it's a little bit different. Similarly, in Objective-C, different than C++, is when you write a constructor. In Objective-C, you actually have to explicitly create the value of self, the equivalent of this, and then also return self. So in C++, our constructors return no value because the value is always a pointer, right? In Objective-C, constructors return an ID, which is a void pointer, the equivalent of a void pointer in C++, but they actually return a value. So a constructor in Objective-C is just like a normal method. It just happens to return an ID or what's the equivalent of a void pointer. So the very first line in an Objective-C constructor would be self equals super, call the parents constructor, which in Objective-C is NSObject. And the last line of the constructor is return self. And everything in between is the stuff that you do in the constructor. But you're ultimately returning a pointer to the object that you just created, where a language like C++, even though it's basically just as old, assumes that, look, this is a constructor. It's going to return a pointer. We don't need you to actually put return yada, yada, yada in there. We'll just have it boil down to the value of this, which is a pointer. All right, what else? See, now we talked about Objective-C craps on the exam. I won't ask you Objective-C stuff. I should put that on there. It's not any harder. It's the same crap. All right. Other questions you have about the so just as logistics for the final, I don't know what day our final is supposed to be, but I'll have all my finals up by Sunday night, and they just need to be turned in by, let's call it midnight on Friday. You'll have to do the whole thing in a single sitting, but I don't care when you do it. Because effectively Saturday, I'm just going to sit down and grade everything. I'll probably do some grading during the week as exams come in, just so I don't have a death Saturday, but so there's a chance if you do the exam early, you'll get a grade earlier in the week as I get to it, but you probably won't see the solution released until I've graded all attempts. But in any case, that's the idea. So you can decide where that fits into your other final exam schedule, your travel schedule, whatever. Doesn't matter to me. I just have to have grades turned in by next Tuesday. All right, so let's just flip through the slides and I'll kind of point out the things that I think will be most important. I'll just throw a reminder out there. Remember, we have that Bible homework that's due by the end of the semester. So it's reading John 1, John 2, John 3, and having a little feedback thing with it. If you haven't done that, it's not due till the end of the finals week, but do it so you get the points for that. It's basically 10% of your grade, 3 points, as long as you take it seriously. I mean, if you write something stupid back or something like that, you're gonna probably get a 0 on it. But just read the Bible, write a response to it, you get 10% of your grade. That's Christian university stuff. Don't screw your grade up over something that it won't take you that long, or it's good bathroom reading material. Yeah. Did you do it in the bathroom? He doesn't want to admit to it either.
Okay, did one.
All right. So you heard it here. Make sure you do that. Also, a couple people asked about like the extra credit from the hackathon. I have it marked down. So you would have just gotten your normal grade for that. But if you did both things, you attended the hackathon and did the other assignment, I have it in a spreadsheet where you'll get extra credit onto your final grade. And what I typically do is I'll apply it where you need it most. So for instance, if you had a 0 in some homework assignment, I might just fix that. If you need a bump in your exam scores or something like that to kind of get you to that next half letter grade or something, I'll put it there. So I try to direct it where it will most benefit you instead of somebody who, you know, if you have 100% homework average, getting another 100 in a homework assignment doesn't change your grade at all. Doesn't help. So I'll try to push it in the right direction, but I do have those listed in a spreadsheet. And not that many people did both. I mean, it's like maybe 8 people total across all my classes, but I do have them. Okay. All this stuff, compilers, things like that, these should be second nature by now. I'm not going to ask about that. Header files, pretty similar to the midterm. I probably wouldn't require you to write header files on the exam. It would be possible for me to give you a header file and ask you to implement the parts of it, something like that. So maybe I would give you a header file and put comments before like maybe 2 functions and say, this is what each function does. And then you show me that you understand that step of going from a header file to the implementation file. And, you know, how do you actually, you know, include the whatever header and then implement the couple of things, that kind of jazz. But on an exam, I typically don't ask you to write a whole bunch of extraneous busy work stuff. I want to see your ability to write some things. So maybe an average, you know, if you think about what I'm testing on an exam in a 3rd semester programming class, it probably has most to do with your current computer programming competency, not your understanding of linked lists or something like that specifically. I want to see how you've improved since 250, since 200, because at this point you should be a more experienced, more advanced programmer. You know, less advanced than you're hopefully going to be when you're done with your degree, but you should definitely feel like you're substantially stronger now than you were in 200, something like that. Let's see. Definitely understand pointers. I probably am not going to ask you a question like, what is a pointer? But you should be fairly comfortable with memory and stuff like that. Now, related to that, it would be reasonable for me to maybe show you a picture of a linked list or something like that, and then give you a scenario. Like, let's say we want to swap the position of, you know, 2 values, or we want to add a new guy in between these 2 values. Write out the steps it would take to do just that insertion with you know, temporary pointers. So rather than like a whole function, like show me the 6 lines that accomplish you not having half the list float out into space, that kind of thing. It would be fair game for me to ask you a hello world again. We've probably beaten that dead horse enough times, but if I'm looking for a final question, it would be fair game. You should definitely be able to write. That kind of falls into that category of, as computer scientists, we're wielding programming languages as kind of like weapons, and a good skill set for us to have, because we have that underlying programming skill set. You know, we got to be able to create variables, write loops, write functions, things like that. But a good underlying skill set would be when you sit down in front of one of the core languages, you have that hello world template so you can just get started. I have a working program in this language, now add stuff to it. So I would guess I'm not going to ask you that question in the exam, but it would be fair game. I think we've asked it enough times. Hold on. This was when I was adding stuff from a different class, right? Oh, no. This is when we were talking about the transition to header files being kind of like interfaces in Java. So again, probably not going to ask tons about this. This was more midterm stuff. Header files, you should already be comfortable with those, but it would be possible that I would ask you to write a header file for something. That actually wouldn't be a bad question. Asking you to write, given some scenario, show me the header file for it, which implies that you should understand that a header file is not an implementation. A header file is the 3 or 4 functions and maybe the private fields for a class, something like that. But you're not actually implementing them, you're just writing the headers for them. So you should understand the purpose of a header file and be able to write one. I probably wouldn't ask a question that has a single question that has you do both, but you should understand the purpose of a header file and be able to write a header file, which actually should be easier than the implementation side. But almost the test there is to see that, do you understand that it's easier? Do you understand that the header file is just kind of a summary of what you will be doing as opposed to the actual doing part of it? So I suspect that if I asked a question like that, I would get a percentage of the class that wrote a whole bunch of code in there and trying to implement the stuff in the header file instead of just the header, the header things for your functions. Okay. Definitely be able to create objects in C++. Not everything's going to necessarily be about linked lists. So like we looked at the card example where, we had 4 fields, things like that. So this is just object-oriented programming. Doesn't matter whether this is C++, Java, Python, you can create objects in any of those. If I say, hey, here's this question, create an object that holds these types of values, you should be able to just write that at this point. That should be very second nature to you at this point. Go ahead.
And when you say like create an object, you mean like create like constructor for it, or make an instance of an object?
Well, could be both. I mean, so I might ask you to create a class and then create 2 instances of that class, proving you know how it works. And I would expect that those instances would be somewhere like in a main, not, I think when I've asked this question before, I get like the instances created at the bottom of the constructor. You should know where those things live. The class itself is a blueprint. Then you use that class in your program someplace else. It would also be fair game for me, maybe at the top of the exam, I might say, although with the way it works in Blackboard, I have to do it on an each question basis, but I might say, given this information, you have a class called A, a class called B, a class called C, and this is what the constructors take. Create an instance of each of those or something like that. You should understand that the classes are blueprints. Using them is when we actually create instances of them, and you should have that differentiation in your mind. Definitely understand what JSON is. I don't know if I'd ask the question specifically about it because that's less of a programming thing and more just it's an important thing, but it's more about how does data move between various applications. And I'm not sure how super, super important it is in terms of you showing me that you're a better programmer. Ultimately, that's what I'm testing. I'll keep coming back to that when you're writing this exam, I'm looking at how have you evolved as a programmer. I won't any of the web stuff. That's something you can just look back at documentation and stuff for. I won't ask about that. You should know the difference between a singly and a doubly linked list going both ways, forwards and backwards. I probably wouldn't have you implement a full linked list on the exam or something like that. I might give you, say, hey, this linked list exists. Remember, this was a weakness on the midterm, right? Where, I asked you to like, assume you have this, add another function, write a function that does something with that linked list. Don't reinvent the wheel. If you have a linked list that already has 3 or 4 functions in it for adding stuff to the front, adding things to the end, stuff like that, your implementation, when I see you use that linked list, shouldn't involve you connecting up next pointers and stuff like that. Use the linked list. You want to add something to the end? Call your linked list .add end. Now it's on the end magically. All right. So make sure you're using the tools, not If you're writing something inside of a linked list, that's when you might use manipulation of the pointers. If I say you have a linked list, now use it to solve some other problem, at that point, you're probably leveraging that tool, right? You're not opening up the chainsaw and screwing around with stuff on the inside to cut the tree branch off. You're just starting it and pushing the button. Yeah.
So just refresh my memory, doubly linked lists have like two nodes connected, two pointers connected to each node.
Yeah, because a doubly linked list, a node knows about who comes after him, but also knows who comes before him. You have a next node and you have a previous node. It's still a linear linked data structure. It's still a single line. You don't have two child nodes off of it. I guess technically you do kind of have two nodes you point to off of it, but they're arranged linearly. You just know who comes next. You also know who's behind you. Because sometimes it helps go in both directions for solving certain problems. And what is it costing you? It's costing you one more pointer. So whatever the size of a pointer is in that operating system, probably 64 bits in most of so 8 bytes in most of our modern operating systems. But realistically, how often as a professional developer would you actually be writing a linked list? Probably not very often, because these things are built into your languages. So then why learn about linked lists? Well, because understanding how these linked data structures work allows you to now write other kinds of classes and things like that that might have pointers to other classes. That concept of having an object that points to other objects is very much commonplace on the things you might be writing. That concept of having collections that hold data, very much commonplace in software development, right? Making that decision, do I know how many things? If I do, put it in an array. Do I not know how many things? Well, probably need some sort of elastic list, whatever that is. These are things that are important underlying concepts, but ultimately that idea of linking up pointers and stuff like that is something you're likely to do all the time in your professional career, but you probably wouldn't actually implement a straight linked list unless you were doing something very special for some specific problem, because linked lists are already built into almost every single language. I probably wouldn't ask you anything. I just saw insertion sort of on there. I probably wouldn't ask you anything about writing a specific sort, but I would say that showing you a merge sort, like saying, here's a list of elements, show me what the different children, the different recursive calls, what portions of the list they would be looking at in the right order, proving you understand how that algorithm works. I wouldn't maybe have you write the code, but if I gave you 4 elements, you should say, well, here's the first whole list, then here's the left half, and then the left half of that, and then the right half of that, and so on and so forth. Showing me the different steps of breaking that down might be fair game. Definitely be able to work with stacks, push and pop, and peek. We had looked at Towers of Hanoi for that, but effectively that's a linked list, right? A linked list where we remove front, we add end. I'm sorry, we remove front, we add front. It's both ways. Q is remove front, add end. So here, a skill, this is kind of what I was just talking about, that professionally you might not write a stack. These things already exist. But notice how, like in our case here, when we wrote Towers of Hanoi, we created an object called a tower that behaved like a stack, right? But then had some additional rules on top of it. It wasn't just a plain Jane stack. It was a stack that had some bouncers at the door that only allowed things to be pushed onto the stack under certain circumstances. So that's the type of thing that you would run into professionally, where you have to solve a problem that feels like it's one of our typical abstract data types. But at the end of the day, it isn't actually one of those guys. It just behaves a lot like one of those guys. There probably wouldn't be a strong differentiation between stacks and queues. on the exam. Stacks tend to be easier to ask questions about, but you know, whatever, be prepared for both. And frankly, I don't care if you say remove front and add end, or if you go NQ and DQ, which are the official functions for a queue, as long as you understand that you're using a data structure that implies that things are only added one way and things are only removed another way. That's good enough for me. Linked list is like a generic structure. Stack is a implementation, a simplified linked list that just says only these two things are allowed. A queue is also a simplified linked list that says only these two things are allowed. Okay. Nonlinear linked data structures, that's going to be something that's going to be, well, wasn't represented on the midterm, will definitely be represented on the final. But like I said, asking programming questions about these sometimes they're hard to come up with those questions. So there probably will be a question on there where I show you a binary tree and I ask you to tell me what order would you visit the nodes in if you did an in-order traversal, a pre-order traversal, a post-order traversal. Almost guaranteed that question will be on there. So I'll show you a picture of a linked list and say what would happen. Where you're just going to give me a list of the node values. This is the order I visited them in. And the punchline should be, if it's in order, I should see the numbers in order. is the punchline. Go ahead. Yeah, because we didn't really cover the other ones other than just the idea that from a searching performance perspective, an unbalanced tree can be problematic. That's probably something that's more appropriate, like an advanced database class where databases are typically represented as binary trees. So from our perspective, just from a computer science, a generic computer science perspective, just that understanding that the more balanced a tree is, the more even the left and right side are, the better average performance you get for searching it would be. That's more of a knowledge trivia tidbit thing a computer scientist should have. But again, in terms of what I'm testing, I want to see how you've evolved as a programmer. So the questions on the exam are going to be not that dissimilar to things you've maybe seen in the 250 or 200 exams, but maybe just a little bit more advanced because you should be able to handle more stuff on in the same amount of time now that you're a more advanced programmer. And I'll try to use linear linked data structures, but there's no guarantee. I mean, there'll probably be a programming question on there where you take in a string and have to manipulate the string in some way or build a new string, something like that. And again, since it's, I don't want you to go and type this in and compile it and run it. So, if I can read code. So as long as your syntax is close-ish to, something reasonable, you're showing me that you know how to solve a problem. I don't really care. I mean, I want you to write it in C++, but if you end up making an assumption that, strings can do this in C++, where maybe they don't quite just work that simply, but you've pretty much shown me you know how to solve the problem, I'm not taking off points because of something that the compiler would have screamed at you about. You would have done a quick Google search and see, oh, this is actually how you do that. With that, I want to see how have you evolved as a computer programmer, as a problem solver, taking an idea and turning it into an implementation. And I want you to write that in as close to C++ as possible. All right, so if it's obvious that you're just writing it in Python, just to write it in Python, I'll probably just take off all the points because it's equivalent to like a punching you in the face or something like that. So try to make it C++, but I'm going to be pretty forgiving with a little syntax caveat here and there. It's not that big of a deal. So this slide right here, I would say pretty important. Make sure you fully understand. This is slide 72. Okay? Make sure you can get those numbers out of in order, pre-order, post-order. Because there will probably be a question almost identical to this slide on that exam. That's 10% of your grade. All my exams are 10 questions. So the difference between a 90 and 100 is this slide. All right. Go ahead. What kind of question? Oh yeah, there has to be. Yeah, at least one conversion question. Probably only one conversion question. But man, if you had a 325 exam, you should see a conversion all over the place. Man. Plus hiding things. So, I mean, have you guys done like bitwise shifts and stuff like that in 325? So if you have like a 16-bit register and you want to hold 4-bit numbers in there, how can you make that work using bitwise ands, bitwise ors, and rate shifts? Oh, I love asking those questions. It's not hard though. I promise you it's not hard. I make it fun and you'll see that it's not hard. It's just like a puzzle. You know, I have 16 bits to work with. I have 4-bit numbers. Well, I can put one of the numbers in these 4 bits. I can put another number in these 4 bits. I have another number in these 4 bits. I have another number in these 4 bits. But when I read from it, I'm always reading the last 4 bits. That means I have to get values down there and turn everything else into zeros. It's easy. It's like just a bitwise and. It's a zero if it, what's this? Yeah, that's all it is. You know, it's no different than in real life. You have a box that can hold a bunch of stuff, but you only want to hold 4 things in there. So you kind of have to segment the box, but then you have to play the rules of how do things come out of the box. You got to make sure they get shifted into the right place. So when you take the value out, you know, you have the right value. It's no different. Same stuff. Yeah, I always do. That's why that stuff is fun. All this user interface crap. Who needs a user interface? If everybody just understood the bits and bytes stuff, and we wouldn't have that problem. Yeah, it's the coward's way. Trust me, people who are good at design and user interface, I see that as a superpower because it's not a strength of mine. The closer we get to the circuit, the stronger I get. I don't even try to. I can only draw Teenage Mutant Ninja Turtles, and only their head. That's it. It's my full talent in drawing. I used to do that with the grape juice boxes on our ceiling. And my parents hated that. Man. It's true. It's true. You can go for walks. Everything's flat. Yeah. Yeah. I played tennis. That was part of my TED Talk too. I used to play professional tennis. Yeah, I played Division I tennis and broke my back. And then I got fat because I broke my back. I've always been, that's all related to the competitive eating. I've always been a huge eater, but if you play 7 hours of tennis a day, it doesn't matter. Then you break your back and you stop playing 7 hours of tennis a day and you're still eating tons, now you get fat pretty quick. But it also translates into why I'm pretty good at golf. Golf I can play. My broken back does limit me some on like the distance I can hit the ball, but I can't still play tennis because tennis, if you move and you have to stop, the physics of having to stop all your weight and then switch directions is terrible on my back. But golf, I'm just turning around my hips, and a lot of times I'll go out there, my back hurts, and I pop something in as part of my swing. But my tennis skills translated into golf. So I have a very good short game and stuff from just kind of the touch from tennis. I was a serve and volleyer back when those still existed. Yeah, interesting backstory. Yeah, well, I mean, but the thing is, all those things, all those experiences added up to what we have today. And that's true for everybody, right? You know, there's been plenty of moments in my life where I thought this was a terrible thing. I can't believe this happened to me, yada, yada, yada. That now I can look back on and say, had that not happened, I may have taken a different path that put me somewhere that I'm glad I'm not. You know, could I have been the next Pete Sampras? Maybe, probably not, right? Probably living out of my parents' basement, you know, letting them pay for me to go to the next qualifying tournament to try to make it into the main draw at one of these professional events, continually getting, you know, killed by these better players, even though I thought I was really good. There's a lot of really good players out there at the professional level. So probably worked out okay. Not great on your health though. Yeah, it's not amazing, but you know, what is it? What is it? YOLO? What's this? Yeah, now I have a Tesla. It just drives me around. It's good. And now it's wrapped. So my logo's all over it. It's awesome. I even specifically didn't take Emily's advice for the font. Yeah, it's awesome. And then, so I got it Monday, and I've already had 100 hits on the website with form posts. Yeah, it's just, I'm telling you, it catches people's attention. And people you see it on the highway are like, awesome fat. What is that?
I don't even know what it is.
Exactly. It was my TV name when I was a competitive eater. That's what awesome fat was. And then I attached it to a software company. So it was the name of one of my software companies. And now it's my consulting business where I teach people about cryptocurrency and programming education and stuff like that. Basically, I just get paid for knowledge. I'll meet with somebody over coffee, charge them a bunch of money, and hopefully add value to their company. Don't have to do anything other than drink coffee. And they usually buy. It's great. Well, now, I mean, I'm retired. I sold all my businesses in 2014. Now I'm just a lowly professor / golfer. Mostly golfer. That's why I only teach the classes I like. That's right. So at some point, if you're interested, you can have coffee. I can give you the whole backstory because it goes way deeper than all that. No, students always get it for free. You're already paying enough to the university, aren't you? I don't need the money. Just my time's worth something, but you're already paying for the time. Plus, I really like coffee. Pretty often, I give away this knowledge for free. So if I can get people to pay, that's great. But most of the time, I just really like the logos. Makes me feel like a king. When I'm walking around the country club, people just call me awesome or awesome. Actually, it's usually awesome, like short for awesome fat. I've been there for like a decade, so they all know me from. I just like that as an ego thing. Know thyself, right? That's also all true. It just is what it is. Yeah. And it's kind of because I do all the food reviews, because I'm still stuck with, because now I'm like, I don't eat like I used to in terms of quantity, but I'm like a foodie. So I like all these interesting stuff. So like, you know, it's like I'm the Godfather from the movies where like the chef comes out and like clears the specials menu with me, like before they make it public to, which seems weird, but I like it. Is this acceptable? You bore me. Ay. All right, let's keep powering through this. Well, that's a usual thing. I've been off topic for 21 years. No, we won't. We won't. And then it'll just be a surprise on the exam, and I'll ask some question we didn't even cover in class, and I'll just curve it back in. It'll work out. Yeah, I'm a reasonable guy. You know, you get half the class messaging you saying, look, we didn't cover this. Yeah. You just shut up and take your grade. And then I go look and like, yeah, we didn't cover this. Right, exactly. Right. It's the same thing. There's the slides. We finished them. All right. So anything you want me to review? Anything you want me to cover? One thing to keep in mind to remember for the exam, if I do ask a question dealing with arrays, remember that in C++, arrays are not able to report their length. So you would need to write if you wrote a function that took an array in as a parameter, you would probably also need to take in an integer that said the number of elements. Go ahead.
How do you do the
I probably wouldn't have you do it, but it's pound define max nums 15, something like that. But I don't think I'll ask you a specific question about macros or anything. That's more of a language caveat. C++'s version of a constant that it's equivalent to Java's final keyword. You've seen that before in any documentation. But it actually doesn't have a type associated with it. So this doesn't even get resolved to a type. It just goes through your code, and anywhere it finds that word, it replaces it with that. And that's a preprocessor situation. So it actually rewrites your file at compile time before it even tries to compile it. Yeah, it could be anything. Because really, it's not resolving it. It is literally going through your file and saying, search and replace. Find this, replace it with whatever this is. So if you're in Swift, it could be an emoji. Oh my gosh, I've told you that before. Oh, Swift supports emojis as variable names. It's completely stupid. It's ridiculous. No, we don't need to go back to hieroglyphics. Yeah. Yeah, and we would say that's a problem. Yeah, I mean, I get these text messages that are like 11 pictures in a row, and you're trying to decipher this thing. You feel like you're some kind of Egyptian archaeologist. Like, what is this person trying to say? Reminds me of the. I'm trying to think what was the name of the movie where John Cena was in it. They were parents, and their kids were going to prom, and they were reading their text messages, and the text messages they were planning what was it called? Right, yeah. Right, yeah, I won't say that in recording, but yeah, that was it. That was it. So the parents get wind of what their plan was, but but they had to like figure out how to translate the emojis and what they meant. Yeah, so half the time when I get like messages from younger people, I don't even know what this is. So you just reply with the LOL or the winky. It's usually a neutral reply that everybody just kind of, yeah, it's fine. An emoji GIF. Oh, but is that still an emoji or is that a GIF? Yeah. Yeah. Right. But that one's not an emoji. That's actually his own AI. It's built in. That thing hunts. that thing hunts. Yeah. Not a fan. That would be the ultimate who would win in a fight? Mr. Gonzalez or Chuck Norris? No. Mr. Gonzalez was lethal at 2 weeks old. Lethal.
It looks like you and Dr.
There's been a cougar sighting in our neighborhood, and Mr. Gonzalez already named the cougar and has befriended him. Her name's Misty. Yeah, this goes deep. Yeah. Yeah, hence the meeting this morning where you just said you're still crazy. it's kind of, yeah, I'll take it. It's fine. All right. Anything else you want to cover, review, whatever, before the exam? All right. Exam will be up before midnight on Sunday. I mean, there's even a chance I'll have it up earlier than that, but it'll definitely be up by midnight Sundays, and you just have to turn it in sometime by the end of the week next week. We do have senior seminar presentations because there are a couple of students who are doing it off schedule. I'll put the links up. There's not a requirement or anything like that because there's only like 2 or 3 students. We're doing it one night, but I'll put the link up if you are interested in watching the, I want to say it's maybe Monday night, Tuesday night, something like that. It's only one night. They are senior projects, but this isn't the semester that class usually meets. These are students who needed the class to finish and for whatever reason didn't take it when they were supposed to. It's Monday night at 7 p.m. And I think there's only 3 of them, so it should be done by like 8:30, 8:45. I'll put the link up in Slack if you're interested, but come and support the seniors if you'd like. I don't know if any of the projects seem overly, I mean, they'll all be fine, but I don't know if anything like seems like it's going to be a mind-blowing experience type thing. But yeah, if you are available at 7 p.m. on Monday and you want to jump on a Zoom call, even if you're just logged in to support the graduating seniors who needed the class, that might be a nice gesture. All right, questions, comments, concerns, bribes? All right, I will see you when I see you. I'm around all summer, so if any of you still live in the area, I'm always up for coffee or whatever.